Namaste everyone, welcome to the class. Now today we are going to see a very important topic. The topic is functions. Now in the previous lecture we have seen what is a relation. Now let us discuss what is a function. A relation f, now this small f we use for function. So a relation f from set A to set B is said to be a function if element of set A has one and only one image in set B. Okay, what I said? I said that a relation f from set A to set B is said to be a function if every element of set A has one and only one image in set B. Okay, I will explain you this with the help of an example, but before we give example we are defining it. So this is the definition. We can give another definition for set for a function. I will say that a function is a relation. A function is a relation. This is a special type of relation. So a function is a relation from a non-empty set, from a non-empty set A to set B such that the domain of function is A and no two distinct ordered pair in F have the same first element. Okay, so function, two definitions I have given. A function f from set A to set B is said to be a function if a relation f from set A to set B is said to be a function if every element of set A has one and only one image in set B. So every element of set A, okay, so this is very important, every element of set A has one and only one image. This is also very important. So if your relation satisfies this condition, you will say this relation a function. Or other definition I have given, a function is said to be a relation from set A to set B such that the domain of f is A. So the same thing, our domain of the function is set A, okay, and no two distinct ordered pair in f in function have the same first element. So first element should not repeat. So if I define two sets, say set A, I will define 1, 2, 3 and I will define a set B as say 1, 2, 3, 4, 5, something like this. Then we can define one function as 1, 1, 2, 3 and 3 comma 5, something like that. So here both the conditions, that first of all each element of set A must have an image. So here you can see that 1 has image 1 in set B, 2 has an image 3 in set B, and 3 has an image 5 in set B. Okay, so each and every element of set A must have some image in B. And second condition is what? Second condition is that, okay, second condition what we have said, that key it has one and only one image. So here we see that key 1 has only one image 1, 2 has only one image 3, and 3 has only one image 5. Now I can represent this function with the help of arrow diagram. So here let me draw an arrow diagram. So here I will define set A, in which I have 1, 2 and 3. I will define a set B, in which we have 1, 2, 3, 4 and 5. 1, 2, 3, 4 and 5. So using arrow diagram, one has relation with 1. So the image of 1 is 1, image of 2 is 3, and image of 3 is 5, something like this. So this is your function. So all the element from set A must have some image, and they must have one and only one image. So that means when you write in roster form, the element from set A must come only once. So first element, if you see, all the first elements are different. They should be distinct. They should not repeat. Okay, if it is repeating, then it is not considered as a function. Now we have understood what is function. So let us write some special functions. Let us understand some special function. Before we understand some special function, one more thing need to be clear. What is a real valued function and what is a real function? Two things. First is, what is a real valued function? Now as the name suggests, real valued means the final answer what I will get, the value of the function will be some real number. So then it is called real valued function. So if my result, my value of the function, or I will say that the set of image will be a real number or it will be a subset of real number, then the function is said to be real valued function. And if domain is also real number or subset of real number, then it is called a real function. So when domain and range both are real, then it is called real function. And if only your range, or you can say that value of function is real or subset of real, then it is called a real valued function. Now how we denote function? What is the notation of function? So a function from set A to set B is written as function. I will write f and I will write A first, and then I will show arrow and I write B. So this is how I write a function. This is read as function from set A to set B. Now here, if A and B are the two elements belonging to function, okay, then A will be from set A and B will belong to set B, small b. Okay, small b should belong to set B. So A should belong to set A and B belong to set B, and AB belong to function. This is our function from set A to set B. I will say that this value B is nothing but it is f of A. Okay, B is image, actually A comma B belong to function, so B is image of A. A is called pre-image of B, B is called image of A, and I can say that B is equals to f of A. Okay, generally we write f of x with y. So y is equals to f of x is some kind of relation in terms of x. y is equals to f of x. So y is my function. So here whenever we are defining function, there are two terms. Okay, one is domain and one in range. Okay, there are two elements. It is a set of it is ordered pair, set of ordered pairs. So in that ordered pair, the first element represents the independent variable and second element represents the dependent variable. So the first element represent the value of x and second element represent the value of function. We also denote with y. So let us discuss few standard functions. First function which we are going to discuss is identity function. Let us understand what is identity function. So I will define a function f from R to R, that is domain is real number and range is also real number. So function R to R given by y is equals to x. Y is what? Y is f of x. So when your f of x is equals to x, then the function is called as identity function. Now we can use graph paper to plot the relation between the value of function and the value of independent variable. So here in this case, in identity function, we can easily figure out that when the value of x is say 1, the value of fx, that is value of y, is also equal to 1. So here along x-axis we show the value of x, along y-axis we show the value of function. So 1, 1, I will get a point somewhere here. Value of x 1, so value of fx is also 1. Value of x is 2, value of fx is also 2. Value of x is 0, value of fx is also 0. Value of x is minus 1, value of fx is minus 1. Value of fx is minus 2, value of fx is minus 2. So we get a straight line like this. This is my function y equal to x, and this function is called identity function. I can write fx equal to x or I can write y is equal to x. So this is your identity function. Now let us see the next function. Second, it is a constant function. Constant function. Now as the name suggests, constant function means the value of function is going to remain same whatever will be the value of x. So y, which is fx, now here this y equal to fx is going to be some constant c. Then we will say that the given function is a constant function. Now this constant function is also defined from real number to real number. So a function defined as f is equals to r to r. Okay, f is a function from set of real number to set of real number, such that y is equals to fx is equals to some constant c, where x belongs to real number. So here x belongs to real number, and range of this function, if you say range, so in range I have only one element, which is c. Now can you draw the graph for this constant function? This is your x-axis, this is your y-axis. Now whatever will be the value of x, value of y is fixed, which is c. So suppose this height is of c. Then when x is 0, y is c. When x is 1, y is c. When x is 2, y is c. When x is 3, y is c. So I will get a line which is parallel to x-axis and passing through point 0, c. So at every point the y coordinate is c. So this is the function y equal to constant. Now this function is called constant function, as the value of function remain constant whatever will be the value of x. Now let us see third function, which is called as polynomial function. Now third function is polynomial function. Now this polynomial function is also defined from real number to real number, means the variable which we are going to supply will take real values and the value of the function will also be a real value. Now this function, polynomial function, so it will be of the form y equal to fx is equals to something like a0 plus a1 x power 1 plus a2 x power 2 plus dash 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 and so on, an into x power n. This is my y is equals to fx. Okay, now here in this case n should be integer, okay, non-negative integer, and value of n should be an should not be equal to 0. So then this is considered as polynomial equation in degree n. So let us take a simple example. If I take y, which is fx, if I take y is equals to say x square. Now this is also a polynomial equation. Here the degree is 2. Now how you can plot the graph? So to plot the graph, I need few points. Now take the value of x and value of y. Let us take few points. So when you take x 0, what will be the value of y? This is also 0. When you take x is equals to 1, the value of y is also 1. When you take x is equals to 2, the value of y is 4, because it is 2 power 2. 2 power 2 is 4. When you take x is equals to 3, the value of fx is 3 square is 9. Similarly, if you take the negative values, like if you take minus 1, the value is plus 1 because it is a square function. When you take minus 2, it is plus 4. When you take minus 3, it is plus 9. So the value of y is remain positive, whether the value of x is negative or positive. Now let us plot it. So when x is 0, y is also 0. So this origin represent that point. When x is 1, y is 1. So suppose this is that point. When x is 2, y is 4. So for 2, the value is 4. So little high. When x is 3, y is again high, which is 9. So 9 is somewhere here like, and then I will join this side. Now if I take the x value negative, then for minus 1 I have value minus 1. For minus 2 I have value 4. Okay, for minus 3 I have value 9 and so on. So I will join this something like this. This is your graph for polynomial function. Y is equals to x square. Here I have taken a very simple polynomial equation, y equal to x square. So you can see that this is a curved, okay, curved shape which is opening upward. Okay, so polynomial function. Okay, there are different types of polynomial function which we will study when we see polynomial equations in 10th standard. Similarly, we can draw the graph for x cube. Now next I will discuss a rational function. Cubic function, you understand cubic function. Now for cubic function, when x is negative, y is also negative. So if I draw the graph, I will get something like this. So something of this kind is y is equals to x cube. In the same manner you can draw for x power 4, x power 5 and so on, but you will not get problem beyond x power 3. Next is rational function. So what is a rational function? So rational function, if I define a function f from r minus 0, okay, if I define rational function, or say r, it could possible that it will be r minus something, that something is what? So before that I will discuss the format of rational function. So here rational function y is equals to fx is equals to function of x divided by another function of x where this denominator part is not 0, then this kind of function is considered to be rational function. Denominator should not be 0, because when denominator is 0, it becomes not defined. So y is equals to fx upon gx, where gx is not equal to 0 is your rational function. We can take a simple example, y is equals to 1 upon x. Now this is a rational function where x should not be equal to 0. X can take any value, but it should not take value 0. So my function is defined from r minus 0, because you are saying that your x should not be equal to 0. So the value of x, this first part is value of x, so the value of x could not be 0, so I have excluded 0, and the value of the function could be any real number. So a function defined from r minus 0 to r, okay, is a rational function. In our case, numerator part is 1 and denominator part is x. Now what I will get when I draw a graph? You can easily see that when the value of x is less than, it is positive, but when it is less than 1, when it is less than 1, denominator become greater than numerator, and I will get the value of y, denominator will become smaller than numerator, and I will get the value of y more than 1. So as you approach, as the value of x approaches towards 0, the value of y is keep on increasing. So I will get a curve like something this, okay. So when x is positive, okay, when it is more than 1, so suppose here it is 1, so for 1 I am getting result 1, but when it is more than 1, say 2, so the value of function will be 1 upon 2, 1 upon 2 is 0.5, when it is 3, it is 1 upon 3, when it is 4, it is 1 upon 4, so value of fx is keep on decreasing, okay, value of fx is keep on decreasing as my x is increasing. So x is increasing, value of fx is decreasing, and on contrary, if the value of x is less than 1, okay, so then as x is decreasing, the value of function is increasing, so you will get something like this. In the same manner, we will get a curve on this side also, it will be something like this, okay. So this is a graph for y equal to 1 upon x. Now quickly let us discuss few more functions. So next function I will discuss is modulus function, okay, modulus function. So modulus function is again it is defined from real number to real number, but the format of y is equals to mod of fx is equals to whatever expression we want to write, we can write, okay. So y is equals to mod of fx, y is equals to, modulus function, a special type of function, modulus function. Here I will say that y, which is fx, this is equals to mod x. Now mod x always gives you a positive value, whether x is a negative or positive, your result y will always be positive. So I can redefine this function as y is equals to minus x when x is less than 0, because when x is less than 0, the value of y is negative, and when I multiply this negative number by negative, I will get a positive value, which is my requirement, because y is equals to mod of x. Similarly, I will say that this is equals to x for x is greater than or equal to 0. So when the value of x is some positive value, the value of y is also positive value. When value of x is less than 0, the value of y is minus of that value. So negative and negative, it will become positive. Now if you plot the graph, when the value of x is 1, you will get value of y is 1. So somewhere here you will get, when x is 0, you will get y is 0. When x is 2, you will get y is equals to 2. So something like this you will get on this side. On the reverse side, when x is minus 1, I have answer as minus 1. When it is minus 2, this is x greater than or equal to 0. So when x is less than 0, okay, so for minus 1 it is minus of minus 1, it become plus 1. When it is x is minus 2, it is minus of minus 2, it will become plus 2, and so on. So you can see points like this. When I join, I will get a curve like this. So this is your y is equals to modulus function mod of x. This is y is equals to mod of x. Then I will define one more function, that is sinum function. Okay, there is a big question in your mind that where we are all going to use all these things. So majorly these all things are used in engineering. So my sinum function is also defined from real number to real number, set of real number to real number, in such a way that the value of fx is going to be 1 if x is greater than or equal to 0. It is going to be 0 if the value of x is 0, and it is going to be minus 1 if x is less than 0. So when the value of fx is negative, when the value of x is negative, the value of fx is minus 1, and when the value of x is positive, the value of fx is plus 1, and when it is 0, the value of fx is 0. So if I plot, what I will get? Now what I said, that when it is 0, the value is 0, so 0 is here. When it is 1, 2, 3, 4, anything, it is going to be at 1, so I will get a straight line like this. Now here when x is 0, the function is, when x is 0, I cannot use this value 1. So what I will do, here I will show an circle with opening inside, means you can say that hollow circle, and here you will show it with a filled circle, because when x is 0, the value of fx is also 0. And similarly when it is negative, when x is negative, what happens? Value of fx also keep on negating, is negative. So your function is negative. So you can draw a graph something like this. So this graph indicates that when your value of x is 0, we will get this 0 value. When it is greater than 0, we will get this value which is 1, and when it is minus, when the value of x is negative, we get it as minus 1. So this sinum function is again applicable when we discuss engineering problems. And last, we will see the greatest integer function. Next is greatest integer function. Now let us first understand how we represent it. Fx is equals to mod of x. Fx is equals to, I will say, this bracket. So this is greatest integer function. Now greatest integer function, it gives you the greatest integer which is less than or equal to x. Okay, so fx is equals to greatest integer of x. What is it? It is the greatest integer which is less than or equal to x. So what it means? So for that, let me redefine this function. So I will redefine the function as, now its value is going to be, say, minus 1. I will say that this is going to be minus 1 if x is greater than or equal to minus 1, but it is less than 0. So you can see that this is the greatest integer which is less than 0. Okay, minus 2, minus 3, minus 4 are also integers, but the greatest integer is minus 1 when x is less than 0 and greater than or equal to minus 1. Similarly, its value is going to be 0 when x is greater than or equal to 0 but less than 1. Its value is going to be 1 when value of x is greater than or equal to 1, less than 2. Its value is going to be 2 when x is greater than or equal to 2 and less than 3, and so on. Now how you plot it? So the next big question is how to plot. Okay, so we have plot so many functions. Now you try to yourself, let us plot it and then check the solution. Okay, so here for greatest integer function, now this is your x-axis, this is your y-axis. When the value of x is greater than or equal to -1 and less than 0, greater than or equal to -1 and less than 0, so from here to here the value of function is -1. So -1 is somewhere here along y-axis we show. So I will show from here to here a straight line. Now when the value of x is -1, the result is -1. Okay, when the value of x is 0, okay, it is not -1, its value is 0. So what I will do, I will show an open circle at this point. I will show an open circle at this point. Similarly, when the value of x is between 0 and 1, my result is 0. So I will show something here. Okay, let me use a different color because this is also white. So I will draw a line like this and I will use an opening here. Then from 1 to 2, 1 is included, so its value is 1. So I will start from here. I will show something like this, then this opening bracket, then from here I will start, I will show like this. So this value is 1, this value is 2, this value is 3. Okay, this is your greatest integer function. Okay, so majorly we have seen most of the functions, how we can plot them on the graph. Now let us discuss algebra of real function. Now in algebra of real function, we will see how we can add two real functions, how we subtract one real function from another, how we multiply a real function by some scalar, and how we divide one real function by another. So first we will see addition of two real functions. So here I will define a function f, where I have to define two functions. So I will define one function as f. Now this function f is from x to r. Now what is this x and r? So they are nothing but they are two different sets. R is always a set of real number, x is set of some other numbers. So I have one function f x to r and I have another function g. This is also from x to r. Then I can define sum of these two functions as f plus g as a function. This is also from x to r. Now this x is a subset of r. Okay, so f plus g, this is a function from x to r given by f plus g of x will be equal to fx plus gx for all x belonging to set x, for all x belonging to this set x. So this is addition of two functions. I have one function f, one function g. I can add these two functions as f plus gx as fx plus gx. In the same way you can discuss or define subtraction. So in subtraction, if you have one function from x to r and you have one function, this is also from x to r, then we have f minus g as a function from x to r, such that f minus g of x will be equals to f of x minus g of x. Third operation is multiplication. In multiplication we have a function f from x to r and we have a real number, say alpha, and alpha is a real number, then we can define a function alpha f, or then I will say that alpha f of x, this will be equals to alpha into fx. This is multiplication of a scalar by a function. I can multiply two functions. So if I have one function from x to r and I have another function from x to r, then I can define product of these two functions as fg. Now when I write fg, that means I am defining product of these two functions from x to r such that fg of x will be equals to fx into gx for all x belonging to your set x. And finally we have division of two functions. So again, if f is a function, so I have f a function from x to r and g a function from x to r, then I will define f by g. I will define f by g of x as fx divided by gx, provided this gx should not be equal to 0. So this is division of two functions. Okay, so here we have seen what is function, we have seen some standard functions, and we have seen some operations on functions. Now quickly let us discuss few problems, okay, so as to reinforce our concept of function. Okay, so here this is our first problem. Now which of the following relation R function give reason if it is a function, determine its domain and range. So now here you can see in this relation I have to check whether this relation is a function or not. So in this relation we can say that 2, 5, 8, 11, 14 and 17. Now first element, all first element are different. Okay, so this can be a function. Okay, which of the following relation are function? So here in first case I will say that this relation is a function. Now why I will say that this relation is a function? This relation is a function because each first element, okay, how we have defined a function, that there should be only one, okay, only one image of each first element, or in other way what we can say that there should be no two distinct ordered pair which have the same first element. So here I will say that because no two distinct pair have the same first element. Now they have not given set A and set B. Okay, we have to define set A and set B based on the given information. So here the question is, which of the following relations are function? Give reason if it is a function, define domain and range. So it is a function because no two distinct pairs have the same first element. So here I will say that domain, now domain is set of first element. So first element we have 2, 5, 8, 11, 14 and 17. So domain is 2, 5, 8, 11, 14 and 17. This is domain. And range, so for range I will see the second element of the pair. So 1, okay, all are 1 only, so range is 1. Now the second one, this first is a function. Now let us see what about second. So let us first I remove this, I will write here only. Second is, now if you see the pairs, we have 2, 1, 4, 2, 6, 3, 8, 4, 10, 5, 12, 6 and 14, 7. So the first element is distinct. So here again I will say that the given relation, for second I will say the given relation is a function. The given relation is a function because no two distinct ordered pair have same first element. So first element, if you see, they are all different, so this is a function. Now here we have domain, we will define domain. So domain, here we have 2, 4, 6, 8, 10, 12 and 14, and we define range. So in range you have 1, 2, 3, 4, 5, 6 and 7. This is range. And the third one, is it a function? So the answer is no. What I will say that this is not a function. Why it is not a function? Because here 1, 3 and 1, 5 have same first element. Okay, the first element should be distinct, so this is not a function. So as this is not a function, we need not have to define domain and range of this relation. This is a relation but not a function. Now second question, find the domain and range of the following real function. Now domain means all the possible values that x can take. So here in the first question, where your fx is minus mod x, then here x can take any real value. So I will say that domain, here our domain is real number and range is all possible values this function can take. Now as whatever will be the value of x, modulus will give me the positive value, and this positive value when we multiply with a negative value, I will get a negative answer. So my range will be from minus infinity to 0. Okay, so if this is 0, this is minus 0 and minus 0 plus 0 are same, so 0 will be included here. So I will write like this. This is my range, domain and range. Now second question is fx is root 9 minus x square. Second question is fx is equals to root 9 minus x square. Now the value of this root 9 minus x square is real. So for real value, this 9 minus x square should be greater than 0. So as this is a real valued function, this is a real function. So as I will say that as fx is real function, this 9 minus x square should be greater than or equal to 0. So when I say 9 minus x square should be greater than or equal to 0, this gives me the value of x square should be less than or equal to 9. This gives me the value of x greater than or equal to minus 3 and less than or equal to plus 3. Okay, so whenever we have x square less than 9, this is how we get the answer. Now if you see on number line, minus 3 square is plus 9. If you take a greater value, it will be like minus 2, minus 2.99, something like that, and its square is going to be less than 9. Okay, if I take lesser than minus 3, then it will be say minus 4, and square of minus 4 is 16, which does not satisfy this condition. So whenever you have inequality, okay, this is how you find square roots. So x will lie between minus 3 and plus 3. So what is my domain? So therefore I will say that domain means all possible values of x. So here all possible values of x are between minus 3 and plus 3. So to represent it, I use this close bracket minus 3 comma plus 3. Now this close bracket indicates that this minus 3 and this plus 3 are also included in my set, and all values between minus 3 and plus 3 are also included. So this is domain. What is range? Range is the possible value of this square root. Now this is a positive square root, so first its value is going to be positive. Now the value of x is between minus 3 and plus 3. So what are the possible values of 9 minus x square? So when x is 0, 9 minus 0 is 9 and its square root is 3. When x is minus 3 or plus 3, its value is 0. So between 0 to 3, I have the value of fx. So I will say that range here, what is range? So range is from 0 to 3. This is range. So domain and range we have discussed for this. I hope it is clear. First and second question. Okay. Now let us move to this third question. A function f is defined by fx is equals to 2x minus 5. Write down the values of f0, f7, f minus 3. Now fx is given 2x minus 5. So first I will define f0. So f0 will be 2 into 0 minus 5, which is equals to minus 5. Then I will define f of 7. So for 7 what I will do, and this function in place of x I will replace 7. So this will become 2 7s are 14 minus 5. So 14 minus 5 is 9. And then I will take f of minus 3. So f of minus 3 is 2 into minus 3 minus 5 is equals to, this is minus 6 minus 5 is equals to minus 11. So f of 0 is minus 5, f of 7 is 9 and f of minus 3 is minus 11. The function t, which map temperature in degree Celsius into temperature in degree Fahrenheit, is defined by T of C is equals to 9 upon 5 times C plus 32. Okay, so T of C is equals to 9 upon 5 C plus 32. Temperature in degree Fahrenheit. Now this T of C, this is temperature in Fahrenheit. Here C is in degree, and this is how I can convert from degree to Fahrenheit. Now I have to find T of 0. So T of 0 will be 9 upon 5 into 0 plus 32. So this is 32. Okay. So that means when my temperature is 0 degrees Celsius, its equivalent value in Fahrenheit is 32 Fahrenheit. So 32 Fahrenheit is same as 0 degrees Celsius. Now T of 28. So when temperature is 28 degrees Celsius, it is 9 upon 5 into 28 plus 32. So 5 1s are 5, 5 5s are 25, 3 30, 35 6 are. So 5 into 9.6, 9 into 5.6 plus 32. So 9 6 are 54, 5, 9 5 are 45, 45 plus 5 is 50. So this is 50.4 plus 32. So this gives me 82.4. This gives me value 82.4. This is t of 28. Similarly, you can find t of minus 10. Okay, so t of minus 10. T of minus 10, what I will do? 9 upon 5. Then here it is minus 10 plus 32. So 5 ones are 5 twos are. So this is minus 2. This is minus 18 plus 32. So 12 minus 8, 4. 2 minus 1 is 1. So this is 14 degree Fahrenheit. Okay. So degree Fahrenheit we can write its unit. Okay. Now last is the value of C when Tc is 212. Now the value of Tc is given 212. Now what is Tc? Tc is, so therefore I will say that 9 upon 5 C plus 32. This is given 212. So therefore 9 upon 5 C will be 212 minus 32. So this 2 minus 2 is 0. 11 minus 3, 8. This is 180. Okay. So therefore we have 9 upon 5 C is equals to 180. This implies C equal to 180 into 5 upon 9 is equals to 9 2s are 18. So this is 20 into 5. 20 into 5 is 100. So that means C is 100. C means Celsius. Okay, 100 Celsius. So I will say that therefore temperature is 100. Now this C is in degrees Celsius. Okay. So when 100 degrees Celsius is there in Fahrenheit, its value is 212 Fahrenheit. So this is in Fahrenheit. 212 Fahrenheit is equals to 100 degrees Celsius. You should remember these two values, that 0 degrees Celsius is 32 Fahrenheit and 100 degrees Celsius is 212 Fahrenheit. Okay. Now let us move to the last question of this exercise. Find the range in each of the following function. We have to find a range. Okay. So first question, fx equal to 2 minus 3x. Now x is greater than 0 and x belongs to real number. So the value of x is greater than 0. So when x is 0, if I take x is 0, what I will get? I will get answer 2. Okay. Then when I take x as 1, so 2 minus 3, 2 minus 3 is minus 1. So as I keep on increasing the value of x, the value of fx will also keep on increasing. Now here I have to find the range. So let us discuss this in this way. I have given x greater than 0. So therefore value 3x will be greater than 0. Okay. Then therefore this minus 3x, so it will be less than 0. When we multiply by negative value, the sign will change. Greater than will change to less than. Okay. So less than, or I will say that less than or equal to, it will change to less than or equal to. Now 2 minus 3x. So 2 minus 3x will be less than 2 minus 0. So the value of 2 minus 3x is less than or equal to, now 2 minus 3x is fx. So the value of fx is less than or equal to 2. So here we have to find a range. So therefore I will say that therefore range will be, I will not use set. This is for if natural number is there, then I will use this natural number or whole number or integer. But for real number we use this bracket. I will write minus infinity because its value is less than 2, comma 2, and I will include 2 because value 2 is okay. Now let us see, if I put value 2 here, what I will get? If I put value 2 in place of where I am putting value 2. Acha, I have to find the value of range. So when x is 0, but x is greater than 0, it is never equal to 0. When it is equal to 0, then I will get 2. So here where I have written less than or equal to, this is not correct, it is only less than. So as it is only less than 2, I will not use this bracket, I will use this bracket. Okay. So sometime you also confuse like this. So range is minus infinity to 2. Any value between minus infinity to 2 we will get in this first case when x is greater than 0 and x is real number. Now fx is x, here it should be x square. Okay. So some printing mistake is there. Fx is x square plus 2, x is a real number. So fx is x square plus 2. Now x is a real number. X is a real number. X can take any value. What value the fx will take? So first thing is that k x square, as this is square, x square is greater than or equal to 0. So therefore x square plus 2, this is greater than or equal to 2. So therefore what is range? So I will say that range is greater than or equal to 2. So 2 will be included and infinity will not include. So from 2 to infinity is your answer. Fx is equals to x, where x is a real number. So fx equal to x. Now this is fx equal to x, this is your identity function. Here your range, you know that x can take any value. So your range is minus infinity to plus infinity, or you can say real number r. R is the range. So in exercise they have given simple questions, not too difficult questions. We have solved all the problems given in this exercise. In functions you could have more complex problems. For that you can refer any of the reference book like R.D. Sharma or any other book. Okay, or better you refer NCERT exemplars. Yes, so along with NCERT you should always see NCERT exemplar for more questions. So in this chapter we can say that this much means the chapter is relation and function. We have understood what is relation as well as what is a function. We have seen domain and range of functions also. Yes, so thank you for being with me in this class. In the next class we will see a new chapter, or maybe we will see some miscellaneous problem from the same chapter. Thank you.